Okay, so in this problem, we have the array of words, and then we have array letters with corresponding score. Uh, Looking at the constraints are really for small. The words array of the words array size is 14, and the length of each word is 15. So it's like go 14 into 15, which is not really big. Mm, it's around 30 to 7, so 210 characters. Then we see at the letters length dot letters length. Letters length is also around 100. Okay, so basically we have to select a subset of the words array. Then we have to check if it is possible or not. If it is possible, then we can basically greedily select the ones with the highest score and add it. So I think calculating the maximum score will not be really difficult, but finding um, generating the subsets, since it's in 100, I don't think. No, for words, since 2 to the power 14, right? Right. So, number of subsets of words will be around 2 to the power 14. From 2 to the power 14, we can actually, first we will generate the subset using bit masking. Followed by that, we can check if, uh, okay, then we can actually start calculating the score. So if at any point of time, let's say there are in a given subset, we are needing three C's, but in the array there are two C's, so one C is extra needed. So in that case, when we go, we will actually find that it is invalid case. So we will make the score negative in that case, and I think that can be done easily. So yeah, I think it's possible. So let's generate all the let's generate mm, all the subsets. So we can first make n equal to words dot size int mask the size number of subsets. Just one thing I need to check, power of 2 to the power 14, how much is it? It's nearly square root of 2 to the power 10 to the power 9, because 2 to the power 31 minus 1 is 10 to power in terms of 10 to power 9. So it's 16,000. It will pass. So um, mass will be forward. If I equal to 0, I less than plus I. Okay. I sorry. I less than mask. I can do it like this. And so j equal to 0. J less than n. Sorry, j less than around 32 plus j is the fitting integer. If I and j, right? In that case, this is the case. So here, if I and j, so we have to include the word j. Jth element of word needs to be included if the bit is set. So what can we do? Okay, so letters and words are actually corresponding. So what we can actually do is store mm, can letters and score we can set store in some map or set data structure actually. Um So for corresponding each letter, we will have a like a map of set might be desirable in this case. And each time we will actually find actually yes, this since the number of letters are there actually 26, so we can actually have a vector of heaps of size 26, right? Also, since it's 100, the data structure won't be actually really big. So let's try that. Now, or not vector, a map actually. The map character, comma, priority to int, right? Can actually name it MB map. So for int m equal to letters dot size, since it's one to one corresponding letters and P, 6 and 8, 9. Okay. Um, no, I think I have got the approach wrong here. Acha, no, it's score size will be okay. So it's actually the problem is actually easier now because each letter will have a particular score, so we can actually map that, or we can no, we don't need to map actually. Uh, we can put the letters in a multi-set, right? We can put the letters in a multi-set actually. So we need to create that multi-set every time, and there is a loop for 32 and letters length is 100. So actually we will go each time for mask can be put of 16,000 into 100 will be our complexity. So 16 into 10 to the power 5, almost 10 to the power 6 complexity. If we include uh, a loop where we will create a multi-set every time inside uh, each mask. So it's a multi-set car ST here and for auto say, letters. So let's uh, see, right? So where we actually need to do this. So every time we are creating a multi-set actually. mm, okay, if I and J. So for so now for each letter, what we will do first, we will make a score int score equal to 0, and above we will have an int answer equal to let's say 0, which we will return because since score minimum score will be 0 obviously, so we are initializing it with 0. Now for every valid letter in the subset we can do auto c words words j. st dot find c. Let's just keep the address since it's a multi-set. Okay, we find C. If okay, Now, if in case it's valid, like IT equal st dot n, that is, it's an invalid case. This following subset will not be able to make due to lack of characters. So what we will do actually, we will make score equal to int min, and then we will break. Okay, but this will come out of this loop. Okay, so to even break out of the second loop, right? Score is int min, then we go here, uh, we break out of this loop. If I and j, then here is the, I think we can put here, if score equal int min, we need to break, and here actually we can do it answer equal to max of, we are comparing with the score every time. So since it's zero, score equal to int min will actually never affect anything at all. Mhm, score equal to int min, right? Okay, nice. Else, if it's a valid case, what we will have actually have to do, score plus equal to, 4 plus equal to, oh. So actually we have already a vector named score, so I cannot keep this variable as score. So let's just call it step. Okay, so step for this is step by step. Step equal to int mean, and if step equal int mean, step, okay. Finally, step plus equal to, score of, um, C minus A. Putting back. This will be index since it's like A, B, C, D. So A minus A 0, B minus A 1. That's how we work. Score equal to step plus equal to score. And then actually what we do, st dot erase IT. Right. So this way we can keep track of everything. This I will see is not. I think this should give us the answer. Okay, we got address sanitizer. There could have so I could I. Hmm. Okay, let's just start from one for example. Wait, still. Hmm. Okay, so for this loop, I don't think there we have any problem. This is this. Let's just do this for now. I think in the inner loop there might be a problem. Yeah. Yes. This I think will be actually an working, but it's still giving me zero. Acha, we need to check for every bit, right? So it won't be actually J, it will be one over J. We need to mask every bit from 0 till 10. Okay. Can actually do something. See out, I, see out, see out, bird, J. We have it's got birds, J, and also this will tell if the generation is going correctly or not. So it's okay. So we start I from one, yeah. So first there is only dog, in two there is only cat, in three there is dog cat, in four there is only dad. Yeah, its subset generation is going fine actually. It's really fine. There's no issues with that. Um, because like it's the first element is 0 1, second element 1 0 0 0 1 0, third element 0 0 1 1. So these are including subsets are being properly generated. So let's see where the problem is. For each step for if this here, if a word is included, we are adding it to the score, and yeah, it's working fine, I guess. Here it's breaking out of this loop. So yeah, should not actually cause problem. Acha, we are returning zero. We need to return answer. See if this works. Okay, it's working fine. Now let's the example cases and see what's the result. Yep, it's correct. Now let's see there is no zeros there for here. Okay, good. So actually what we can do, there are two zeros. So we can actually add another zero here, another two here, and D there are two, there are three, and another D. So in that case, I guess it will sum up for everyone. Oh, yeah. So I think this case should also work. We will get a much higher answer than 23. So no, we are only getting 23. So is this the maximum possible? For with dad and good. With dad and good, it is maximum. So dad, we are forming DAD, good, we are forming GOD. What about dog? Eh, Acha, we need another G then. Right. Yeah, it's 33 now because the cases like dog, cat, dog, good, everything is being formed, I think. Yeah. Oh, there is no T, so there is dog, dad, and good. Okay, I think this will work. TLE won't be a case. You can get a wrong answer. Yeah, it's done. It's